Hi everyone, I'm Jayaprasad, this is Megh. Um, Today I think the focus is, we all know about deep learning quite a bit, but we want to enlighten the audience about how far we've arrived in terms of some of the use cases. Some of the use cases that we are planning to show here, or even the demos that we are planning to show here, look fairly futuristic, but they can be made practical and available with the building blocks that are in play today at this point of time. And the overall idea is, how do we utilize this state of the art to build better real-time user experiences for a fintech use case? And we'll talk you through a few interesting demos that we have lined up.
Absolutely, Jay. And I think, it's been really exciting since morning. Like, there were some really power-packed sessions. And we really wish with the demos and the technologies that we're going to present, I'm sure it will, fill up the room with a lot more excitement. So with that, today, as you must have seen in a lot of other presentations as well, one of the key technology that might have been highlighted quite a bit was AI and machine learning. Right? And one of the reasons why these technologies have sort of become so important today is majorly because of these three factors. The first factor is because of this Cambrian explosion of the data that's happening across the industry, be it in terms of speech, text, images, videos, and so on and so forth. The second innovation essentially happens at the algorithmic level, where these deep neural networks, as we would like to call it, these set of algorithms have become so advanced that we are actually able to solve highly sophisticated problem with real high accuracies that can be put in production. And the third is obviously, with the rise of the computing. So with that, we have just highlighted some of the most common use cases that you would actually see in the future of fintech. One of them, obviously, is the digital avatars. So in a sense that, today, what if you could essentially go to any organization like a bank and others, and there you can start talking to a virtual assistant that will help you to navigate through the problems that you have. Or if you would like to get a specific process completed, how can that digital avatar help you to do it much faster? Essentially, the goal is to have a much better customer experience, reduced queue and delay times, and much more interactive and informative information through these agents. There are also a lot of other use cases associated with video analytics, in a sense that, I'm sure all of you must have seen the Amazon Go store, right? And you would have seen how they are essentially trying to make the entire process of shopping seamless without the need of a lot of people there, right? That means you just walk into the store, you pick up something that's of interest, put it in the checkout cart, and just move out, and everything, right from tracking to understanding which products are bought by you to the digital payment, all of that is done seamlessly. So
we will walk you through 3 or 4 interesting demos. And most of these revolve around building blocks that are available right now, meaning they look fairly interesting. And we'll walk you through some of the building blocks there. For instance, we are starting with a conversational avatar, which we are going to show shortly, where basically you take in signals from both audio as well as the camera. You figure out what is the dialogue that you're going to do with the customer, and then you do a very healthy frame of reference dialogue with maybe more than one customer that you're seeing at that point of time, right? Megh, you want to show the demo?
Sure, absolutely. So just before we get to the demo, what we also wanted to sort of convey through this particular slide was the fact that there are actually a lot of different workloads in place for solving this kind of problem. Right from computer vision, that is going to sort of analyze the people in the frames with whom the avatar is going to have a conversation with. Apart from that, you're also going to have like a speech recognition technology that essentially converts everything that you say into some textual format. And then you have a dialogue manager that is responsible for taking the user through a stateful journey, right? So say for example, if you go to say to McDonald's, say, and you want to say order food, how does that agent take you through that journey of buying different products that you essentially want? And then in the back end, you also would have some recommendation engine as well as natural language processing coming into the play. I think more on that with the demo. So
Hi, welcome to Shannon's Cafe. How can I help you?
Can I have a cheeseburger with a side of onion rings, please?
Would you be interested in our popular toppings for cheeseburger like bacon and fried onions?
Yeah, let's do it.
Done. Added cheeseburger with bacon and fried onions. What else?
What protein options do you have?
We have multiple options. I recommend the double protein burger. Would you like that? French fries, onion rings, and fried pickles. What would you like?
I'll have the French fries instead of the onion rings, please.
Sure. Would you like some garlic on it?
Yes, please.
Okay, I have added French fries with garlic to your cart. What else?
What salads do you offer?
We have market salad, Cobb salad, fruit salad, and side salad. Side salad is popular with our cheeseburger.
I'll do the side salad.
Alright, it is sunny out there. Would you like to add some drinks? I recommend our lemonade.
Sure.
I'll have a cola.
We have two options, Diet Cola and regular cola. Which one would you like?
I'll take the latter, please.
Adding regular cola. Anything else?
That's it. Thank you.
Okay, your total bill is $24.46. Your food will be available shortly. Thank you.
Thank you.
Thank you. Bye.
So, very interesting example. And if you're looking at this closely, we are taking speech, we are taking computer vision cues, we are tracking each person separately, right? We are tracking what responses have what actions. So when they added a burger or a fries, it added on to their basically list of things which would be billed for. The bot also started suggesting a few things over and above, right? Now, from prima facie, it would look as if we are showing a slightly futuristic movie which might happen in 1 or 2 years down the line. But this is possible right now. The amount of heavy lifting that some of these building blocks can do today is amazing. Right from the perspective of even showing the bot and animating the bot. Now, the bot is even looking at these two characters, so these two individuals on the screen. If necessary, the bot could even build them separately, which we are not doing as a part of this example, but it's very easily possible in the sense that now you are basically doing identity management on the bot side. You're taking their choices independently. You're associating speech and choices made by those people to the identities that the bot has identified, billing them separately, and even it can carry out the payment separately. We've not done that, but that can be easily done. As you saw, it's able to figure out the two individuals separately and what they are doing. It's looking at their IQs also, meaning what we have not taken that into account. But those are interesting emotional, sentimental cues that can be taken from the environment as far as this particular tech is concerned. So that kiosk is a fairly loaded sensory input for this entire system because it's speech heavy, it's vision heavy, right? And not just that, it's able to articulate the people very cleanly. It's able to even identify. If we had done something like iris recognition, basically you are even biometrics happen there as a part of the overall exercise. Now, so we'll show you one more associated demo. Can I complete this one? Right, we'll take questions after this one. And this is more than the previous demo in the sense that the bot over there was able to answer questions related to shopping and the product catalogs. It had complete understanding of the product catalog. It could do recommendations over the product catalog. It could figure out the weather is sunny. Maybe you need this right now as a part of your overall order. Now here we are just shifting to something different. We are shifting to much more general purpose questions, right? We're going to utilize an avatar which has been created here for the purpose of this demo. But the questions are fairly general knowledge in nature, and this entire exercise is going to be natural Q&A, right?
Hi.
Hello. Hello, Toy Jensen.
Hi, please ask me anything.
What are the greatest threats of climate change?
The greatest threats of climate change are the effects on human health, food security, water supplies, and the environment.
How do astronomers look for exoplanets?
Most exoplanets are found via the transit method. That was the case for the TRAPPIST-1 planets.
Tell me more about that method.
The transit method is when a planet passes in front of its star. The amount of light blocked tells astronomers the size of the planet. The duration of the transit tells astronomers the orbital period of the planet.
What telescopes use that method?
The Kepler Space Telescope used the transit method to find thousands of exoplanets.
I've heard about a satellite called TESS that is used to find planets. How does it work?
TESS is a space telescope that looks for transits.
What roles do proteins play in our cells?
Proteins are the building blocks of the body. They are the basic materials from which all living things are made. They are needed for the structure, function, and regulation of the body's tissues and organs.
How do they work?
Proteins are made up of amino acids. Amino acids are the basic building blocks of proteins. There are 20 different amino acids that link together in different combinations to form different proteins.
How do they catalyze chemical reactions?
Proteins are biological catalysts. Catalysts are substances that speed up the rate of a chemical reaction without being consumed by the reaction. Enzymes are proteins that catalyze and increase the rate of biochemical reactions in the body.
Thank you. Goodbye.
Sure, anytime.
We'll be deep diving into some of these, how these been created and how you can do some of these things yourself too. But the interesting thing is we've taken this toy character. The voice has been synthesized to sound like the toy character, the person behind the toy character, which is Jensen Huang, CEO of NVIDIA. And the way we've been able to do it is, even if you take like a 30-minute video recording of Jensen, we should be able to synthesize how Jensen sounds like. And it's not just me, although you're seeing NVIDIA logo being applied here, but these tools are fairly open source in nature. You can basically build them yourself. The interesting part about this is there is a general purpose questionnaire being asked to this guy, meaning I'm calling it general purpose, but you're asking very specialized questions in the area of astronomy, astrophysics, and the like, right? And he's able to answer that, right? Which means that there has been a large amount of knowledge which has been utilized as a part of training for this particular question and answering session. Megh, would you like to go through or deep dive some of these?
Sure, absolutely. I think there was a question maybe we
Right,
can
we'll take the question.
Yeah.
So, the previous demo, right? I'm trying to understand the mix of a guided conversation that is already pre-coded versus what really happens on the fly.
Sure.
So, right, they asked questions, they gave options. So, it's possible to realize it in a pretty low-tech way also. So, in your demo, what was that mix? Because large part of it, those questions could be predicted. I'm trying to understand the component of ML, the AI here.
Sure, we'll go through that. I think so. There are multiple parts here. It's not necessarily guided versus unguided. It's usually at any given point of time, if a question is asked and a frame of reference is kept for that particular individual, you can determine where the question needs to go next in terms of an answer or question answer.
Right.
I mean, mostly everything is guided, but people think that it's unguided or, right? Because when you are building all these blocks, you have a general understanding of what are the set of questions that you could ask here, what are the flows which are possible, right? The system is able to learn all those things. And the system also takes into account these two individuals now. Although these two individuals, we've clubbed them together, their orders have been part of the single final order eventually. But if necessary, I can separate out those two orders.
The interesting part was the question was about suggest some foods with protein. And it gave options, then vegetarian options too, right?
Right.
So for me, I'm trying to understand if that was already anticipated. What if we said instead of protein, give me a carb-rich food or something?
Right.
Would it still have been able to come up with that suggestion without it being encoded or say associated with these words? Each food associated with something already uploaded into the frame of reference.
There is a training component definitely, because you are associating protein components with vegetarian, non-vegetarian foods. And the second part is the recommendation component, which is a recommendation engine working behind the scenes, which says, he asked basically, he changed the conversation saying, I'm not happy generally with what you are showing as a part of non-vegetarian. Was his salient clue. He didn't say that. I mean, can you show something in vegetarian? He said it instead, right? So basically now you have to basically wipe that away, start afresh for that food category that he had mentioned, figure out the necessary recommendations associated with that food category, and then show it to him, right? Yeah. Sure.
So, can this be a personalized one? Let's say, for example, can this be let's say, a diabetic patient? So,
can you hold this?
Yeah. Think about you're putting this in a mall or a big restaurants, right? So, can this be personalized? Let's say.
The building blocks are all there. So, for instance, if I'm able to associate that identity right now, and I'm looking at you, let's say your iris happens to be your QR code, for instance, right? So, can I associate that this is a person who's possibly diabetic? I've seen him in the past someplace at a related kiosk, for instance. Can we bring along those history? Of course, but then now you get into issues related to consensus or consent, basically, rather. I mean, you have to give permission that there are certain related dietary aspects which you are willing to disclose as a part of your health profile to the system. So those are separate aspects, but certainly can be done. The building blocks are there. You just need to associate it as much as possible. Now, what we'll do is we'll walk you through what we've done as a part of this exercise. Megh will walk you through both the input as well as the output side of the exercise, right?
Sure. So as you can see here, right, so these three modalities, which is speech recognition, natural language processing and understanding, and text to speech, is sort of the heart of these conversational AI assistants. Now, if you actually look at the ASR part of things, so I'll just quickly briefly talk about what are the different subcomponents. So here you can see that there are 4 modules within the ASR itself. So initially what you do is there is some raw audio waveform that comes into the ASR module. You have a feature extractor which does specific things like converting these waveforms into something called as MEL spectrograms. And then the MEL spectrograms which are generated by the feature extractor essentially are then fed to the acoustic model. Now the acoustic model is a specialized neural network that maps these MEL spectrogram feature sets that have come in into their textual corresponding output. So it's sort of trying to map the phonetics with the corresponding text. Now, one of the drawback of the acoustic model independently is the fact that it does not have innate knowledge about language. So that is exactly where you have a language model which is specifically text on large corpus of text, which essentially guides and helps to fix some of the corrections from the acoustic model. Now, The NLU part gets extremely complicated because it changes depending on the use case that you're trying to solve. In case of the first example, where there was like a guided flow, you would be doing things like entity extractions, like say, when in that conversation it was said that, hey, can you provide me some protein options? So protein is the keyword based on which there has to be some recommendation that has to be generated. So extracting those important cues from the text, based on those cues forming the next possible recommendation, is something that the NLU engine essentially takes care of. Now the NLU engine for the second example was more of a question answering system. That means if I take a lot of my knowledge base, right, train a very large language model on top of that knowledge base, can I now start answering a lot of these frequently asked questions directly, right? So say for example, typically today, if you want to sort of, you have a question, you would go to an FAQ page of a specific a website, right? Now instead of that, what if you can train a large model that is capable of automatically getting the right set of answers for you based on the query that has come in. So that can be another part of the NLU process itself. And today, we are actually seeing that the world is moving towards building these extremely large, knowledgeable language models, right from Google's to others. Everybody are basically doing this, and all these large models are also available in open source for people to go ahead and start building on top of it. Then you have the text-to-speech system. So based on the insights generated by the NLU system, you want to convert that insight into the raw audio based on the speaker. So now, based on the second example that we saw, we could do this voice cloning just with say 30-40 minutes of that target person's voice. So just to give you an example, if you must have seen, Apple recently announced that their Siri voice assistant will now have voice of Pankaj Tripathi, right? So the world is now moving towards this kind of personalization where they will have a brand mascot and they'll basically capture their voice and start generating some of these answers with that mascot's voice. So you have a TTS system. Again, the flow is very similar. You take text inside, you convert that again into MEL spectrograms, then feed it to the voice encoder, and you are able to generate natural voice from it. Another interesting fact is that these models have become so advanced that you can now even condition on certain emotions. Now, say for example, you want to get the TTS system to speak out a specific sentence with a specific emotion, you can also do that. So there's a lot of great advancement in the algorithms that's happening that essentially is leading to.
That was not clear. Are you saying that instead of exposing it to a knowledge base, a structured knowledge base, the system on its own can go query knowledge systems, ontological knowledge systems, and figure out give you possible answers, and then you train it?
Yes, absolutely. So you have these, so there are two kind of models that you will basically see. One are called as extractive, where you provide a guided knowledge base, and based on the context that has come in, and the query that has come in, it will try to extract the answer within that knowledge base itself. That's an extractive system. The second kind of approach that people are also looking at is a generative system. That means rather than providing this entire corpus that can get queried upon, what if you just have a model that can generate the answer on its own? So there are like two open areas that you can essentially see. Our experience is when you are trying to deal with a closed loop conversation, in that cases having a knowledge base and an extractive system makes more sense. But if you want to say answer some open domain question, so just to that kiosk, I just go and ask that who is the Prime Minister of India? In that case, or say, how is coffee made? So those kind of answers needs a generative model. Right? So again, there are these two different approaches that we choose based on the kind of problem.
Isn't it a simpler search? If I ask it how is coffee made, isn't it translating it to a language?
But that bot has not been made from that purpose. That bot has been made very limited domain. It's meant to have a conversational system with you, with the domain being menu and its associated properties, right? Food properties related to it. But, sorry, it was not me speaking into the mic. But if you look at the second example, it's a much larger corpus that has been made available for training for that purpose. So you can ask coffee related questions, you can ask space related questions, you can ask almost anything to that bot there. Because the kind of domain that we were exposed to that particular demo, it has been much larger than the one before.
But does that require training? I thought it's going to search a
Right.
data source and read it.
Right. Can I?
Maybe later?
Yeah,
Okay.
we'll take it later, right? Because otherwise it will be a one-on-one question, right? So what we'll show you briefly is the other demo, which is fairly knowledge specific also, but deals with extractive kind of perspective. Now, this is very similar to the first demo, but in like a textual format, right? Here you're not basically having a longish conversation, or you're trying to extract a payments system out of it, but you're basically trying to have a conversation about one particular domain.
What is finance as a subject?
Question: what is finance as a subject? The answer is finance is a branch of economics that deals with the allocation of scarce resources among different uses.
Can you explain what is investment banking?
Question: can you explain what is investment banking? The answer is investment banking is a financial activity that involves the raising of capital for a company or organization by raising equity or debt capital from a group.
Can you explain what is a bond?
Question: can you explain what is a bond? The answer is a bond is a promise by a creditor to pay a debtor a sum of money at a specified time in.
So you can easily see the relation of this particular demo with the second example, where the toy Jensen was basically giving out replies, right? This is just removing the curtains out of the way and showing you what happens behind the scenes. But instead of it being exposed to a much larger general corpora, we are exposing it to a very specific financial domain corpora, meaning you achieve the same effect without the glitz and glamour, but on a textual interface. The building blocks are the same. Right? Yeah.
So in this one, we... Yeah.
Perspective, because bond can be anything, right? Bond can be a personal bond or chemical bond or anything, right?
No, it's contextualized in that finance domain.
Contextualized based on the first two questions?
Yes.
Right. Not first two questions, the training itself. Okay. So if we want to do that, what you are saying, that's a slightly more advanced step, in which case I'm noting down what you're asking over a period of time, then inferring that a bond in this case, in this conversational system with you, would possibly mean a financial bond as opposed to a chemical bond or something else. That will happen in a proper conversational system. Now this is a slightly context-free conversational system that we've shown. But if you did it with the bot, the first bot that we showed earlier, that maintains that conversational system for you.
Yeah, so as you can see in India, this challenge of speech recognition is a lot more difficult, mainly because of certain issues. So first one is the diversity in the number of languages that we have, right? So if you want to say open up such systems to a very large audience within India, you need to ensure that you have speech recognition systems that can sort of understand all these different kind of languages. So that's one part of it. The second is the generalization to different accents of a specific language being spoken in different areas. So maybe the way Hindi gets spoken might be different in, say, the western parts of India versus, say, the eastern parts of India, right? So, or you could have some challenges in the speech recognition system around, say, domain-specific phrases. So what we have done is we have basically will show you how we sort of add the flavor of Hindi with some English words being part of it, and are still able to do real-time speech recognition and translation in real time.
डिजिटल इंडिया भारत सरकार का एक प्रमुख कार्यक्रम है जिसमें भारतीय नागरिकों को सब सुविधाएं आसानी से डिजिटल माध्यम द्वारा उपलब्ध करने का कार्य किया जा रहा है। यह कार्यक्रम भारत समाज को एक ज्ञान अवस्था यानी नॉलेज इकोनॉमी के रूप में बदलने की ओर एक बड़ा कदम है। डिजिटल इंडिया के अंतर्गत ब्रॉडबैंड कनेक्टिविटी प्रदान करने का एक मुख्य उद्देश्य है जिसमें सभी ग्रामीण और शहरी नागरिकों के लिए ब्रॉडबैंड की सुविधा दी जा रही है। आज लगभग सभी शहरी नागरिकों के पास मोबाइल सुविधा उपलब्ध है, परंतु अधिकतर गांव में यह सुविधा पूर्ण रूप से पहुंची नहीं है। भारत सरकार का यह लक्ष्य है कि अगले 5 वर्ष के अंदर इस अंतर को कम किया जाए और हर नागरिक के पास स्मार्टफोन हो, जिसके माध्यम से इंटरनेट और मोबाइल की सुविधा आसानी से प्रदान की जा सके।
So this particular technology has been present only in the last few years. I mean, this when I started doing machine translation like 20 years back, I think this was only a dream. So now we are basically doing a complete pipeline here, which is speech to text or ASR. And then after we get the Hindi part, we are doing the reverse translation from Hindi to English also. Right? And it's doing it in a fashion which is fairly robust. It's not a broken translation at the end of the day. And you're able to see the results almost immediately. You're going to the next step of the pipeline even, and it's able to figure out the previous sentence has completed and the translation should be carried out. So there is an end of utterance marker for the translation to start and trigger off, for instance. And what we are saying is these building blocks are there right now, meaning of course, there has been a massive effort towards creating these kind of systems, especially on the Indian side, because for a long time, Indian languages were left behind purely because I think it was not in favor of Western interests to serve that market at that point of time. But given the kind of scale that we are offering right now as a market, I think it's showing a lot of promise to almost everybody, and everybody wants to enter that space.
So now with that, yeah.
Sure.
Sorry, I came in a little late. I just need to ask a question.
1 minute, we'll take a mic.
Yeah, sorry, I came in a little late. My question is, while you showed the whole translation plus reverse translation, is there any technology or is there already in place of voice recognition in terms of uniqueness of who this voice belongs to? Is that already in place, and that can be developed easily or something
So
of that sort?
do you mean something like given somebody speaking, you want to also identify who that person is?
Speaker.
Yes.
Yeah. So yeah, so there are also a set of modules available to also solve that. Yes, but for that you would need some prior information of some part of speech of that person and an associated tag, and then based on, say, if you want n number of people to be recognized, you can have that n number of samples, and then you can basically train a model to basically do that. But yes, even that is possible.
What's the second part of the question? I didn't understand.
No, this was my question. But the use case was more from to speed up trading experiences for customers.
Okay.
Investment and trading. So by the time you sit and tap, instead if you just speak it out, and it has to translate and the order has to be placed. So, but it has to come from the person who is owning that account.
So there is a general building up / training period for any speech to be associated with an individual.
Okay.
And even on a phone you are aware of, right? Meaning
Yeah.
when Google now or Siri asks for samples
So
initially,
yeah, phonetics.
they are building a profile of what you sound like, right? So as to distinguish you from somebody else.
So
And
something like that can be done, right?
Yes.
yes, it can be done. Meaning, of course, building blocks are available, but commitment has to be available from your side as well
Of course.
utilize this. Can you pass on the mic, please?
About this extraction when you ask a general question. So talk about the extraction. So how do you actually extract? Do you actually search? Let's say if I ask a astronomy related question, so do you search a relevant articles from the internet?
It's not done at real time. It's already there, in the sense that I'm ready for those questions. So if I'm, let's say, building a question and answer session, question and answer system for astronomy, I already have the corpus of everything included. I mean, it could be like astronomy textbooks, it could be astronomy sites that people have, and basically add it to the training corpus. The Q&A system then figures out, given your query, which part of this large corpus does it make sense to return. It ranks it, it figures out what are the bounding boxes in terms of where the answer should start, where the answer should end, and it returns that to you. So that's a retrieval system, basically.
Okay, so when you take that question, will you split up that question and try to understand and
of course,
club it again?
always. But even from a regular query, you need not go into that kind of depth also. I mean, you can just do it at a search level.
Sure,
We'll just flip the switch and go into a slightly different direction. We've been speaking about speech so far, but we'll go to a very interesting use case which you would have seen from the likes of Amazon, about how trade and payment and product placement and product choice can assist in a very seamless kind of a shopping experience, right? Now, we'll play a video which is fairly interesting. Can you pause this? No. No. I think this is interesting for several reasons, because one, you're not just identifying these individuals, you're identifying their pose, you're identifying what is called as a skeletal model of each of these individuals. You're identifying actions. He's picking up an object. The bounding box says so. She is walking, for instance. And for a system as advanced as Amazon Go, for instance, they're able to correlate this particular image into a sensory and join it with a sensory input from the store itself about which product has been picked, to formulate your cart in a real-time fashion, right? So, can you play, please? Yeah. Okay. So we'll wrap it up in the next few minutes.
Yeah, so as you could see, there were multiple, modules involved within this entire experience. So specific to what we saw previously, you have the sensory data in terms of the live feed coming in from the cameras. Then you essentially decode these feeds into certain industry standard formats like H.265 and H.264. Then you essentially do something called as detection, object tracking, as well as pose estimation and action classification. So these are like 4 different models working in parallel on top of this live feed that's coming in. Now, how does this help? That helps to extract that metadata information from those video feeds so that it can be used for other parts of the pipeline, like say the product tracking and also the payment system. So the goal here was to get insights of people within stores or in smart spaces as to where people are mostly crowded, what kind of actions are they doing, and so on and so forth. And again, the goal here is to create a seamless experience of a person going into a store, buying a certain product, and then checking out without any human intervention. So this is what we feel the future of stores would basically look like in the upcoming years. And just to quickly summarize and the main giveaway is the fact that these things might seem that hey, can we really do it? And the answer is yes. We have essentially open sourced a lot of these models for a lot of the tasks that you saw previously in the open for people to basically build on top of it. We absolutely understand that till the time people don't start using it, democratizing these open source tools and softwares, we'll be in a really good position in the upcoming years to actually adopt them and make them seamless for the finance industry. And yeah, in the last part, these are just like some of the technology platforms that were used in creating all of the demos that you saw previously. And again, all of these are open source. So please feel free to go ahead, try them out, and see how it works for your area.
Just to summarize, the idea is that deep learning is now much more approachable as a technology. Of course, there is effort required, but the building blocks are all there in place. If you want to build a much more seamless user experience using either speech or vision or even aspects like Q&A, natural language understanding, all these are possible right now. Of course, the effort that has gone behind the scenes has been humongous. In the last 10 years especially, the amount of effort that has gone to bring us to this capability where we can just use these building blocks and build those 3 or 4 models that we showed you earlier are possible at this point of time. So I just want to leave the audience with this thought. The future is amazing, but you have to utilize the right building blocks, and it's all available in the open source space.